Purpose: finding limited reactants discovered by height of precipitate by two solutions, 0.1 molar copper 2 sulfate and 0.2 molar potassium hydroxide. A limiting reactant is a reactant within a chemical reaction that will rule how much precipitate is produced by the chemical reaction. Limiting reactants can be simplified to daily events we oversee. One example is that a person is making hot dogs. They have 8 buns, 8 sausages, and 5 servings of relish. To make a complete hot dog, the person must have 1 hot dog bun, 1 sausage, and 1 serving of relish. Well, there are only 5 servings of relish, so the person can only make 5 complete hot dogs. Relish is a limiting reactant, as the low quantity of relish only allows a limited amount of precipitate, which are the hot dogs. Materials: well, for our experience on determining limited reactants, we used 2 breads, a metric ruler, 8 test tubes, stirring tool, and a graduated cylinder. For chemicals, we use potassium hydroxide. The amounts vary between 1 to 8 millimeters, 8 amounts of 5 millimeters of copper 2 sulfate, and amounts 1 through 8 millimeters of water. The barrettes were filled with 0.2 molar of potassium hydroxide, then adding 0.1 molar of copper 2 sulfate in each test tube. Potassium hydroxide was added using the volume chart. Water was added to each test tube to create a total volume of 13 millimeters of solution.
The chemical reaction created a blue hue precipitate varying in the color blue. In test tubes 5 through 8, the cubes were filled completely with the precipitate. The precipitate created was copper 2 hydroxide, also a hydroxide ion. The heights of the precipitates using the metric ruler was used to determine the limiting reactants. In test tubes 1 through 4, potassium hydroxide was the limiting reactant. This was determined as the ratio of potassium hydroxide had a direct correlation with the amount of precipitate produced. The more limiting reactant, the more precipitate produced. In test tubes 5 through 8, copper 2 sulfate was named the limiting reactant because the amount of precipitate remained the same. Some sources of error may have been caused by imprecise measurements of water added to each solution, which were measured using a graduated cylinder.